class, you may now take your seat. Okay, so now, have you done eating your breakfast first? Yes, very good. How about you? Not yet. So why? Okay. So next time maybe you eat your breakfast first. You eat your breakfast first because it is so important that we eat our breakfast first before we go to here in school, right? So, and now, since we're done to our last topic or last discussion, of course, last meeting, and now we have a new excited part of our new topic. So, and I know that you are so excited too, right? No, why no? So, yes, so wow, she is very excited. Alright, so before we deep dive into our topic or lesson, let's have our learning objective first. So, our learning objectives here is at the end of the lesson, the student should be able to identify the components of the population variance formula through guided discussion and formula deconstruction. B. Internalize the value of statistical accuracy and ethical reporting by reflective journaling. C. Compute population variance through step-by-step application of the formula using manual calculation. Now, before we deep dive into our main topic, I want you first to imagine you are now a researcher studying the effectiveness of a new drug. Why is it important to know not just the average effect but also how the effects vary across different patients? So what do you think? So why is it important to know? Any idea? Yes? Understand what? Understand side effects. Okay, yes, very good. Another hand. Yes, tailoring experiences. Yes, so your answers are all correct. Is it important to know? Emphasize that the averages only tell part of the story. Understanding how data points are distributed, meaning to spread out. So it is critical for creating a meaningful conclusions and ensuring the reliability of your research findings. And today, we're diving into a tool that helps us measure the spread or distributed precisely, of course. Our topic for today is population variance. Now, class, please listen. Eyes on the board, please. So, okay, this is the formula of population variance. So, what does each symbol represent? So, as you can see, this is the symbol of population variance. So, what does this mean? So, as you can see, x1 minus mean, right? So, the difference between each data point and the mean. So, why do we need to square? Why do we need to square this? Right? So, we are done here, so we go to here. So, we squared this to make deviation positive, so they don't cancel each other out. So, next, what does this symbol mean? So, it tells us to do sum up all the squared, meaning we start here, right? Calculate the mean, and then we square, and then next this to sum up the square. After getting this, we squared, and then to sum up the square. So next, why do we need to divide by n? Since you're done calculating from this calculate the mean and then square it, and then to sum up all the square, right? So we need to divide it by n to find the average of the squared deviation and to get the result of our variance. So our population variance. So since we're done, I'm done with introduce this symbol, each symbol of this formula. So is that clear? Yes, very good. So how about you? Is that clear? Alright, so since we're done I'm done introducing this symbol of population variance. So I want you to imagine something. Think of the formula like a recipe. Each ingredient, it is just like a symbol, has a specific role, and if you don't follow the recipe correctly, the final result, the variance, won't be accurate. Meaning, your recipe are not perfect, the same as the variance. Your variance will be wrong. Activity, let's try. Get a 1/2 crosswise. Try to solve the given data below and get the population variance. Given the score 2, 4, 6, 8, 10. Solve the population variance. You will have 10 minutes to answer and timer starts now. Okay, time's up. Exchange your papers with your seatmate. Oh, why are you laughing? Exchange your papers with your seatmate. They're trying to check if your answers is correct. So let's start with calculate the mean. How to calculate the mean? Of course, we add those data. Let's go here. So copy the symbol of mean like that. So 2 4 plus 4 plus 6 plus 8 plus 10, and then copy the total number of the data. So how to get the total number of the data? So we count the given scores or the data set, right? So 1, 2, 3, 4, 5. So our total number of data is 5. So 5. And then to get the mean, so we should add this data. So 2 plus 4, 6 plus 6, 12 plus 8, 20 plus 10. 30. So here, mean was 30 over 5. So 30 divided by 5. So 6. So our mean is 6. So after getting the mean, calculate this part. As you can see. So next, so by calculating this part, this value, one value minus our mean. So here, copy the open close parentheses. So open parentheses minus 6 close parentheses squared equals 2 minus 6, 4. Very good. 4. So close parentheses and then copy the squared. So 4 minus 6. So open parentheses 4 minus minus 6, close parenthesis, squared equals 4 minus 6. Yes, very good. 2 squared. So next, 6 minus 6. So 6 minus 6, close parenthesis, squared equals 6 minus 6. 0. Very good. 0, close parenthesis, squared. Next, 8. 8 minus 6, close parenthesis, squared equals 8 minus 6. 2. Very good. 2 squared. So 10. 10 minus 6, close parenthesis, squared equals 4. Very good. So now, right, so after getting this part or this result, square this part, alright, so what should we gonna do is to times this result, alright, so equals 4 times 4, 16 equals 2 times 2, 4 equals 0 times 0, 0 equals 2 times 2, 4 equals 4 times 4, 16. So, sum up all the square deviation, meaning add this deviation or this data. So 16 plus 4 plus 0 plus 4 plus 16, and then over copy the number of our data. So 5. So 40 divided by 5. So 8. Very good. Equals 8. So our population variance, or like it should be like this. Our population variance is 8. So, alright, so now we're done solving and getting the results of our data. So the result of our population variance will be given the score 2, 4, 6, 8, 10. Should be 8. Very good. So now, who got the perfect score? No one. Okay, but who got the highest score? Wow, Janice. So now, a round of applause to Janice. So a round of applause. Alright. So now,
Alright. Sit properly, class, and listen. I will group you into 2 groups. Row 1 will be group 1 and row 2 will be group 2. You're going to imagine that you are reporting the result of a new drug. The population variance in patient responses is very high. The question is, why is it important to report this variance accurately even if it makes the drug look less effective? Question number 2. What are the ethical implications of not reporting the variance or misrepresenting it? You're going to represent it here in front through reporting. The reporting will be on our next meeting. Understand, class? Okay, very good. And class, I'll be the one who choose the 2 reporters each group. Is that clear? Very good.
remember students, the components of the variance formula, how to calculate it manually, and the importance of accurate and ethical reporting. Remember again, population variance is a powerful tool for making informed decisions in all sorts of situations. And that's all for today. Thank you and God bless.